So let's start with the 1A. Solid silver chromate Ag2CrO4 forms when potassium chromate K2CrO4 before they wrote K2Cr2. So this 2 is typo error. It should be K2CrO4 was added to a solution containing 0.500 gram of silver nitrate AgNO3. So full stop. Determine I theoretical yield II percentage yield if the reaction yields 0.455 of silver chromate. So the balance equation for the reaction is given. This is it. So that's the balance equation. So let us write the balance equation out. So we have 2 AgNO3, so 2 silver nitrates, then plus potassium chromate. So I ignore the states so that to save space. So Ag2CrO4 plus plus 2 potassium nitrate KNO3. So this is our balanced chemical equation. Let's confirm. We have 2 silver here. We have 2 silver here. Balance. We have 2 nitrates here. We have 2 nitrates here. Balance. Remember the number here, we multiply everything. So we have 2 potassium here. So we have 2 potassium here. We have 1 chromate here. We have 1 chromate here. So we have 4 oxygen here plus 2 times 3, that is 6, plus this 4, that is 10. So we have 10 oxygen there. So we have 4 oxygen here, then 2 times 3 is 6, so that is 10. Balance. We have 1 nitrogen here. We have 1 nitrogen here. We have 2 nitrogen here because this 2 will multiply this. 2 times 1, 2. So we also have 2 nitrogen here. 2 times 1, 2. So that means everything is balanced. Now, we already know that this reaction contains 0.500 gram of silver nitrate. So now, this silver nitrate will give you how many silver chromates. So that means anything we get here with this 0.500 gram will give us the theoretical yield. So this 0.455 given in the question is actual yield in the reaction. So and percentage yield is actual yield divided by theoretical yield times 100%. So now let's find the and all the atomic mass, as in relative molecular mass. I mean the atomic mass is given here. So that is silver chromate. So we are going to use all this atomic mass given. So when we are finding our own relative molecular mass, so know that atomic mass is the average mass of an atom, but relative molecular mass is when you have a molecule. So I'll start with this 0.500 gram of silver nitrates is equals to, so I want to change 0.500 gram of silver nitrate to certain gram of silver chromate. So start with what you have. This will be 0.500 gram of silver nitrate divided by 1 times. Now, how can I remove this gram of silver nitrate? So I need to know the relative molecular mass of silver nitrate. So show that elsewhere. So let's say Ag NO3. So now what is the relative molecular mass for this? So remember, relative molecular mass has no unit, but molar mass has units. So molar mass is the relative molecular mass in gram per mole. That is why I have to find the relative molecular mass and turn it to molar mass. So now silver is given as 107.86 plus nitrogen is given as 14 plus oxygen is given as 16. So that will be 16 times 3 because we have 3 oxygen there. So 107.86 plus 14 plus 16 times 3 is 48. So add everything together. So this will becomes 107.86 plus 14 plus 48. So everything is 169.86 gram per mole. So this means 1 mole of silver nitrate will give 169.86 gram of silver nitrate. That is what it means. It means if I weigh 1 mole of silver nitrate on scale, I will get 169.86 gram of silver nitrate. So I will have 1 mole of silver nitrate will give 169.86 gram of silver nitrate. So that gram of silver nitrate will cancel gram of silver nitrate. So like that. And where we are actually going to is gram of silver chromate. So I'll use this equation, balanced chemical equation, to switch from silver nitrate to silver chromate. So if you look at this, so times, because of space, I should write it here times, but no space. So I'll move it here. So times, so in your notes you can write it straight, as in write it on linear form. So now look at your balanced chemical equation. We can see that 2 moles of silver nitrate will produce 1 mole of silver chromate. So that means the one that will be under must be moles of silver nitrate, so that moles of silver nitrate will cancel out. That means in the chemical equation we already know that 2 moles of silver nitrates will give us 1 mole of silver chromates. So times again. So if this is the same straight line, so you will notice now that so let me put mole here, so you can see 2 mole of silver nitrate. We give 1 mole of silver chromate. So that mole of silver nitrate will cancel mole of silver nitrate. Remember, I said you can write this on a straight line, so it should look like this. Because of space, that's why I write it on that. So it should be like this, so that you can actually see the way it's cancel. Mole of this will cancel mole of this. So like that. Because of space, that's why I write it here. Take note. So times. So 1 mole of silver chromate will give us how many gram? So now we need to find the molar mass of Ag2Cr04. So silver is given as 107.86 times 2 plus chromate is given chromin is given as 51.99 plus oxygen is 16, so times 4. So that means we have 107.86 times 2. That is 215.72 plus 51.99 plus 64, because 16 times 4 is 64. So add everything together. So 215.72 plus 51.99 plus 64 is 331.71 gram per mole. Now this means 1 mole of silver chromate will give us 331.71 gram of silver chromate. So that mole of silver chromate will cancel mole of silver chromate. So we are done with our conversion, because I have converted gram of silver nitrate to gram of silver chromate. So this is the same thing as 0.500 times 1. So I'm multiplying all the up one together, times 1 times 1 again, times 331.71 gram of silver chromate, divided by, then the denominator 1, that will be 1 times 169.86 times 2 times 1. So that is multiply all the numerator, this times this times this times this, ignoring the ones that we have cancelled out, divided by 1 times this times this times 1. So numerator divided by denominator. So this will be equals to 0.500 times 1 times 1 times 331.71. So that is 165.855 gram of Ag2Cr04. So here is Ag2. So that is potassium chromate. Okay, divided by that is silver chromate. So divided by 1 times 169.86 times 2. That is 339.72. So press your calculator, divide 165.855 divided by 339.72. That is 0.488 gram of silver chromate, like that. So that means, so I have to judge this. That means 0.500 gram, 0.500 gram of silver nitrates will give us, is equivalent to 0.488 gram of silver chromate. So this 0.488 gram is our theoretical yield. Theoretical yield is equal to 0.488 gram. So that's the answer for the A part. A Roman figure 1. So everything I've been doing now is A Roman figure 1. So 1A1. So we should do 1A2 now. The 1A2 asks for percentage yield. And note something in the calculation. So you have to know that in percentage yield, due to less purity as reactants or due to some side reactions, yield of products is always less than theoretical yield. So based on stoichiometry. So if you look at the yield they gave us, that is 0.455. So that is actual yield. So that means the actual yield is usually less than the theoretical yield. So you can judge your answer from there. So now the Roman figure 2. So we already know theoretical yields as this. So now actual yield is given. So actual yield is 0.455 gram. So percentage yield now. So the one I'm doing now is II. 1AII. So percentage yield is equals to actual yield of products. So percentage yield is actual yield of products divided by theoretical yield of products. So actual yield divided by theoretical yield of products times 100. So this is the formula for percentage yield. So percentage yield, so I'll short the spelling for percent using symbol. So percentage yield is equals to actual yield of products is given, that is 0.455, which is actually less than theoretical yield. So how you can know whether you are right or wrong? Actual yield of products must always be less than theoretical yield of the product. So 0.455 divided by 0.488, we have gram, so gram will actually cancel out, so that is why I did not put units, times 100. So percentage yield is equals to, so you can multiply 0. This 100 is over 1, so you can have 0.455 times 100, that is 45.5 divided by 0.488. So percentage yield is equals to 45.5 divided by 0.488. So that is 93.24%. So that is our percentage yield, 93.24%. So that is for the II. So we are through its A part now. So let's say the B part. So 1B. 1B. Now we have 4 NH3 plus 5O2 we give 4NO plus 6H2O. So this is 4 ammonia react with 5 oxygen gas to give 4 nitrogen monoxide plus 6 aqua or 6 water. So let's say maybe the equation is balanced. So we have 4 nitrogen here, we have 4 nitrogen here, balance. We have 12 hydrogen here, we have 12 hydrogen here, balance. We have 10 oxygen here, so we have 4 oxygen here and 6 here, making 10. So the equation is balanced. So now, how many moles of H2O will be produced when 0.669 mole of ammonia reacted with oxygen? That means we want to go from moles of ammonia to moles of water. So that is, how many moles of H2O will be produced when 0.669 moles of ammonia reacted with oxygen? So now let's go from here. So we'll start with what we have, 0.669 mole of ammonia. So start with what you have, over 1 times. So how can you remove the mole of ammonia here? Just go to your balanced chemical equation straight. So switch from mole of ammonia to mole of water. So we say that 4 moles of ammonia will give you 6 moles of water. So moles of ammonia will be under. So 4 moles of ammonia, so it's under so that it can cancel out. So mole of ammonia will cancel mole of ammonia. So 4 moles of ammonia will give 6 moles of water. So we have actually solved like that, because what we need is mole of water. Yeah, how many moles of water will be produced when these moles of nitrogen and ammonia reacted with oxygen? So moles of ammonia to moles of water. So we have actually get it that way. So this is 0.669 times 6 mole of water divided by 4. So this will be 0.669 times 6. So that is 4.014 divided by 4 mole of water. So divide 4.014 divided by 4. So that is 1.0035 mole of water. So that is 1B. So we are through it 1B like that. So that means 0.699 moles of ammonia will produce 1.0035 of water. So that is 1B. So you can conclude this will be equals to 1.0035 mole of water in the reaction. So 1C. How many moles are contained in 80 grams of magnesium triisocarbonate 4? So magnesium triisocarbonate 4 is MgCO3. So how many moles are contained in 80 grams of magnesium triisocarbonate 4? That means we have 80 grams of MgCO3. So we want to go from 80 grams of MgCO3 to moles of MgCO3. So how many moles are contained here now? So change this gram to mole. So start with what you have. 80 grams of MgCO3 over 1 magnesium carbonate times. So how can you remove this gram of magnesium carbonate? So find the relative molecular mass. So we have we have 1 mole. So find the molar mass of MgCO3. So that will be, so magnesium, what is the atomic mass for magnesium? Is not given in the question. Carbon is 12, oxygen is 16, so we should be sure. So let me confirm. Let me confirm the atomic mass for magnesium, since it's not given in the question. So magnesium is in group 2. So the atomic mass is 24, as in magnesium is 24.305. So that will be 24.3 times carbon. Carbon is 12. in the, so let's just use 24 for magnesium to just round it up. 24 plus carbon is 12 plus oxygen is 16. So this will be 24 plus 12 plus 48, because 16 times 3 is 48. So now 24 plus 12 plus 48, so that is 84. That means 84 gram per mole. So meaning 1 mole of magnesium carbonate will produce 84 gram of magnesium carbonate, or magnesium triazocarbonate 4, anyone. So that means I'll place 84 gram of MgCO3 under, so that gram of magnesium carbonate will cancel gram of magnesium carbonate. So we know 1 mole of magnesium carbonate is 84 gram of magnesium carbonate. So 1 mole of magnesium carbonate is that. So we already have our answer here. So just multiply. So this is 80 mole of magnesium carbonate divided by 84. So this is 80 divided by 84. That is 0.9524 mole of magnesium carbonate. Answer. So if you want to use formula, so know that number of mole is equals to mass over molar mass, as in that's what you may know. So mass is given, that is 80, and we found the molar mass, that is 84. So 80 over 84, so you still get this. So that is, we want to use formula. So that is the answer for 1C. So we are through with question 1.